Hello, hi. So we're missing one speaker, but we're gonna start anyway. We'll reshuffle as we go. So hi everyone, I'm Matt Turck from FirstMark Capital. Welcome. Out of curiosity, who's new? Who's here for the first time? Okay, so it's a pretty solid group. Okay, awesome. So welcome to everyone, the new people and the returning people. So very quickly, so I'm with FirstMark Capital. We organized this event. We are a venture capital firm here in New York, and we invest in early stage companies, including big data companies. We are hosted by Bloomberg. Bloomberg, as you guys know, is pretty much the first big data company that ever existed, long before the term big data was coined, and they've been an amazing host for this event. And as the people that have been here several times know, so we try to have a theme per event, and we go up and down the stack. So the last couple of events were focused on applications of big data. So the last event was commerce and big data, or e-commerce and big data. The event before that was the application of big data through, legal, government, and finance. But tonight we're going to go back down in the stack, and we're going to be focusing more on infrastructure and analytics. So pure, sort of hardcore big data technology. And we have amazing speakers tonight, and we are going to get started right away. So the format is 15-minute-ish presentation, and then we open up for 5 minutes of questions. We circulate mics, and if we don't have time for all questions, our speakers tend to stay on for the hour of sort of drinking after this, so you can ask them questions then. So our first speaker was going to be Michael, but I don't think he's around, so we'll have him second. So we're going to start with Amit from SiSense. Welcome.
Thank you, Matt. All right, nice to meet you, everyone. I've always wanted to be a warm-up band, never get the opportunity, so thank you so much. Yeah. All right, so I have two parts, actually three parts, two-part in my presentation. First, I'm going to take you a little bit about SiSense and the technology underneath. And second, I was asked to share some of the tips that we use in-house. So I'm going to tell you some of our tips that, how we use analytics. I think it could be a good thought-provoking ideas for the crowd here. So just a little bit about us. All right, yes, we do have dashboards, analytics, SiSense Analytics product, okay, but so do hundreds of other products. What's the big deal about SiSense? And this is the only product that allows non-technical people to analyze big, hairy data without talking to IT, without writing code, just with a few clicks of a mouse. So what's big and hairy data? So the challenge, if you need to join multiple applications, you come from the data world, so joining multiple data tables in a database is a challenge. Joining multiple tables in multiple databases is a bigger challenge. Doing it in multiple applications is a bigger challenge. Doing it in some of the applications are on-premise, some are in the cloud is even a bigger one. And if some of them have billions of records, it's pretty messy, okay? SiSense allows non-technical people, CFOs, marketing folks, operations, sales to do their own analytics with pretty complex data sources. In other words, it's the first product that lets you roll your own join. Or did anyone do it here before? Well, I was in Colorado. They said you're not the first. Okay. So this is a full stack BI or analytics solution. It has everything that you need. Okay. It has a scalable central data warehouse. Okay, that lots of users can share. I'm going to talk a little bit how it works. Okay, but it can scale to terabytes of data and hundreds of concurrent users. Drag and drop, ETL and data joining, just drag, drop, it works in a matter of seconds. And interactive and web mobile dashboards, runs on-premise or in the cloud, all of that with no coding, no clusters, no IT. Just a little bit of the company. We started selling commercially July 2010, growing very, very fast, actually accelerating the acceleration. 2012 doubled. The customer base tripled in 2013. Our origins in Tel Aviv in Israel, and we opened an office here in New York last August. We're 64 people. 70% of our customers are in the US, and we're very excited to be here. Just a little bit about the technology. Okay, how does it work? Okay, SiSense developed something that we called in-chip analytics. Okay, assume who here didn't hear about InMemory analytics? Okay, so in-chip is the next thing. So the idea about InMemory was, let's move the data from the drive to the RAM so we can analyze data faster. Okay, in-chip takes it to the next level. Okay, that uses memory that is available inside the modern chipsets. Okay, first, SiSense is not a hardware solution. Okay, it does work at a hardware level, but it's a pure software solution that works underneath the operating system to exploit what's available in the modern chipset. So in the modern chipset today, there's a good amount of memory, up to 20 megabytes per core inside the chip. Okay? And this memory is 10 to 50 times faster than RAM. Okay? Moving the data between the RAM to the CPU is the bottleneck. So in-chip actually uses the data inside the chip. Okay, it's a pretty small data, but not very small. But actually uses the entire memory hierarchy of the computer to have speed that is faster than in memory without being limited to the size of physical RAM. Okay, which is the biggest problem with in-memory, they're limited to the physical RAM. We're not limited. And so how does it all work? I'm pretty sure by the end of the presentation, I'll learn the difference between forward and backwards in the slides. Okay, so first, it was built from scratch. Okay, everything we wrote, the database, detail tools, and the visualization for the modern 64-bit chipset from Intel, AMD. It's not specific to any particular vendor. It is a true columnar data store and query kernel. Okay, it's not a columnar that is built on a SQL database. It's a true columnar memory mapped database. It uses the entire memory hierarchy. So when we launched in Strata in New York last year, we demonstrated a terabyte of data analyzed on $750 laptop with 8 gigs of RAM. Okay, that got a lot of press. So we're not limited to the amount of physical RAM. In fact, usually I run on my MacBook Air. I run pretty big data analysis fairly quickly. It uses the CPU cache. The data is sliced to columns and then stored in small chunks of anywhere from 64K to 20 megabytes compressed inside the CPU. Okay, so it moves, the operation are done at blazing speed. It uses vectorized calculation. So the modern chipsets have something called SIM, single instruction multiple data. You could add 16 number in a single CPU operation. Okay, so if you want to do total sales over a billion record set, instead of doing a billion add operation, you could do tenth of that amount. So it's a magnitude of order faster. And the final thing is this all allows you to do fast queries on pretty big data. Okay, not petabytes of data, but definitely terabytes and tens of terabytes of data. And it scales very well to a large number of users. Most in-memory product requires additional 5 to 10% per additional concurrent user because they keep copies of the data. Okay, SiSense doesn't do any of that. It stays pretty flat. You could do 3,000 users on a single server without adding additional memory. Okay, how does it work? Okay, that's most databases use caching. Okay, they store query results, and if you run the same query again, it'll run fast. Okay, the problem with analytics is that most people don't run the same query again. You know, I could run sales by product and quarter, and you could run sales by product and category. Okay, not identical caching doesn't work. And to understand how this thing works, you really need to understand how the technology works. Okay, so remember, this is a true columnar algebra query kernel that every every query is broken into tens of thousands of small instruction, machine-level instruction. We have a just-in-time compiler that creates machine-level code, okay? And we use parts of these queries every time that you ask. So and they're stored inside the cache, okay? So the cache can look at partial queries. So if you run the same query again, you'll actually reuse whatever is available in the query store. So the outcome is actually that the more you use the system, the faster it gets. So this is a system that gets faster with more users, not slower. Okay, that's how you can scale to a lot of users. Pretty freakish, but that's okay, so the advantage over InMemory, we have a poster inside. InMemory is not the future, it's already the past. Okay, this is the next generation. 100 times more data. InMemory can process usually tens of millions of records with ease, okay, without doing aggregation. Here you can do billions. Okay. At least 10 times more users, if not 100 times more users on the same hardware, okay, without splitting to server, without adding additional RAM, without adding additional CPUs. Plus, it is schema-free, so you don't need to decide pre-aggregate, pre-join, all those star schema. You can decide on the fly what you want. So very, very flexible to the user. Remember, we said the benefit is users can do whatever they want, okay, without talking to IT, without building the traditional data warehouse in star schemas. Just for comparison, the performance, okay, I read a blog post by, let's say, one of the traditional data warehouse appliances vendors, and they're bragging that to analyze half a terabyte of data would cost you only $500,000 for the appliance and software. We demonstrated Strata in Santa Clara last year, 10 terabytes, okay, analyzing 10 seconds on a sub $10,000 standard Dell server, really cheap stuff. And we were voted the User Choice Award. So that's the power, really simple to use, pretty fast. So that's a little bit about the product. You can see demos online. It's a simple product, really. The technology is complicated. The product is simple. You can download online, play with it, and see how it works. All right, now the second part, okay, I wanted to share how we use part of the growth that we have. You know, it's part of it is a product, but we have a pretty tight operations how we sell and market. And there is a trick that I think is pretty neat. It's very, very simple to explain, but really help drive team performances. I'll talk a little bit in a second. I'll explain. Does anybody know who that woman in that picture is? All right, this is Julie Moss. Okay, Julie Moss became famous, world famous in 1982. That was like way before YouTube. She became a world viral video. Okay, she was, I think, one of the first people to do the Kona Ironman. Okay, and she came just out of curiosity. She was studying psychology of endurance sports and started, and all of a sudden she found herself in a lead position with a very comfortable leads. Okay, 20 minutes lead over everyone else. And then just a couple miles, okay, before the finish line, she collapsed completely and she crawled to the finish line. 20 yards, I think maybe 10 yards before the finish line, she was passed by the second and lost. But that was like a very inspirational video that really, I think, started the whole Ironman triathlon world movement. So while this is inspiring, okay, what I'd like to talk about, how you actually do not crawl to the finish line. I mean, not rely on heroism, but get like more like in a Zen. So fortunately, most people today don't crawl. Okay, and I'm going to talk about analytics, but this is like with the devices that are available today, you have sensors that can, if you hook them up with analytics and some techniques, you can actually pretty much control your pace, and I'm going to get to how you tie this to business performance. Okay, that's something that we use every day at SiSense. But let's start with the example. So really, the idea is you need to pace yourself and adjust your pace to really hit the performance that you want. So if you want to run a marathon, okay, let's say in 4 hours, okay, that's pretty simple. Okay, the pace needs to be about 6.5 miles per hour. Easy, right? I told you. Okay, so the concept, if you set a goal, you create a race plan, and that derives the target pace. Okay. Now, you could tie that thing, okay? How do you know? When you start running, it's very difficult. You could tie this to sensors, okay, and then you see if you're actually running faster than what you plan, you could slow down. If you're lagging, you need to start speeding up, okay? Very, very simple. So ongoing loop in doing that, okay? You could, you know, if you don't want to run a marathon, that's okay, I understand. You know, did you ever board a flight with to wait half an hour in the tarmac and then still make it on time? That's what airplanes do, okay? They have autopilot. Autopilot isn't really a pre-programmed plan. There is a plan, but that plan is connected to sensors, real-time data, headwinds, tailwinds, slight delays, and then the plans is adjusted on the fly. Okay? So that's what you could do with business performance. You could, when you set challenging goals, okay, you tie to analytics, and you hook up, you wire it back with sensors, okay, you get performance that's pretty predictable, okay? That's, I've done it a number of times to deal with a very specific problem that you see in a lot of companies. It's called the hockey stick performance, okay? And we have quarterly targets or monthly targets, it doesn't matter. Usually you'll see that the sales performance is like this, sales or marketing or production or whatever. You'll see that people have performance that spikes at the last minute, okay? The end of quarter, this is really people not estimating the challenge. When you have something that's pretty vague, it's a very long distance, it looks remote, you always think, yeah, tomorrow is still pretty good. What happens, you get pretty much breathless to the finish line. Okay, it's very, very stressful, and then you have another weak start to the following quarter, and you're not working, and that's a vicious circle. Very, very difficult, and that's how you burn out. That's how you crawl to the finish line, okay? That's what happens, 1, 2, 3 quarters, and people are done. So how do we pace? We have a specific system in place that we pace. So let's say that we want to sell $200,000 a quarter per salesperson, and an average deal size is $10,000, okay, pretty round numbers. So that means there are 20 deals that you need to close in a quarter, okay? And let's say add 20% buffer for cushion. So that's 24, so about 2 a week, okay? That's the pace. So it's very simple. All you need to do is do 2 a week, okay? That's the very simplistic plan that you create. And actually we create a plan, a weekly plan that says what does each person need to accomplish every week? Okay, now that's an overly simplistic plan. In reality, you have holidays, you have someone getting married, people on vacations, whatever. So the weeks aren't even. Okay, if you need to consider that in advance. Okay, so in reality, create a plan that is somewhat different. Last week of the quarter, you actually want to set it at 0 to not get to that point. So let's, once you hit the road, okay, once you start, okay, life doesn't always work as planned, okay, and that's how you start adjusting a plan. So let's say that we had to create, on the first week, we had to do 3, okay, and then we did 0. In reality, we'd need to go and adjust the plan, okay? So those 3 needs to come from somewhere, okay? What most people do, they don't change the plan. They just say, oh, it's going to be okay. It's not going to be okay, okay? You need to think how, okay? And the whole point, you connect it again, you readjust the plan on the fly. So every time, every week you connect to the sensors. The sensor are a sales system, and then all right. Let's look at a little more complicated. In reality, the system is more complicated. There are a number of parameters. So based on the sales plan, there is a marketing plan. Okay, other departments need to contribute. Everything is adjusted on the fly. Okay, and also some of the other parameters. Whether the win rate is 20%, so you need to create more opportunities and more leads. Okay, all those parameters are being fed in close to real time. So the way that we wire the system, okay, you have the CRM system. You could do it with Excel, you could do it with pen and paper. It doesn't matter what system you use. It's not doesn't really matter. But when you connect your operational system with analytics, and the spreadsheets, you get the KPIs, the weekly plans, and the sales together. That's how you can pace the system and deliver on time. We have never missed a quarter. Okay, God knows it was challenging at times. Okay, you always have those curveballs, but that's a system. If you connect operation system with sensors, okay, you don't need to crawl to the finish line. So that's the trick, okay, how you finish in more of a Zen line and not to crawl to the finish line if you connect analytics to sensors. So that concludes the second part, and the third part is really questions if you have any.
Thank you. That's a picture of you, of course.
We actually do have one other thing. We actually have a triathlon team. We have a certified triathlon team on board, fully on time at SiSense. So yeah.
Hi, Tony Bayer with Ovum, and I actually have met you folks before. I haven't met you personally. And your technology is impressive, but the problem that I'm having here is that I haven't really heard a real business case for going into in-chip analytics versus in-memory analytics.
All right. The business case is you're not limited by if your data is small, then you're fine. You don't have a lot of users, then maybe there isn't a business case. Okay. But if your data is, let's say, goes beyond 100 million records, you have multiple data sources, you don't want to write code, okay, or lots of users, then that's very, very simple. There's the performance is much better. You need less hardware. It is cheaper, simpler, better. Am I answering your question, or am I missing something?
No. Just put it this way. I understand that going into cache is a lot faster, which means you then have a lot more effective capacity. Technically, that makes a lot of sense. But what types of business problems will this make a difference in?
All right, maybe some examples of how companies use that. Okay, Target is using it to analyze data from 1,800 stores to identify what they call shrinkage or shoplifting. Okay, stuff falling off the trucks or from the aisles. Illegal movements in the pharmacies, okay? Doctors subscribing a lot of refills. eBay is using it to analyze what people are buying and selling online, trends in pricing, new versus old, Samsung versus iPhone, okay? 1.5 billion record set, complex dashboards open in 3 seconds, okay? And lots of small companies that have, lots of data, but not necessarily a lot of bucks or IT. So these are just Merck is using it for clinical trials in new vaccines. NASA, I have no idea what they're using it for. Does that answer your question? Yes, please.
So conversely, if we assume that this
we need a mic, sir. We need a mic, and you need it to be.
Margaret Ost, business-to-business salesperson. My question was related to what he just said. As a salesperson where you need people to pay you money, I was curious, your first customers, were they purchasing as exploratory software, or because they had recognized needs or problems that your salespeople were able to make the connection with?
Usually people have specific needs. I mean, I wish I had people buying for exploratory stuff. Mostly, if there is a very specific need that they're buying. Some companies, it's the BI tool for the entire company, usually within smaller companies, or specific needs within a company. For example, Kellogg's, they're looking to publish various nutritional information of products to a large number of users. There's a specific need mostly.
So just one last quick one. The gentleman over there wanted that I interrupted a second ago. So quickly, like just 1 minute.
Yeah. So if we assume this is great, how quickly do we load this onto AWS or other cloud platforms to start running?
It runs right now. It runs on AWS.
Okay. That was as quick a question and answer as one could hope for. So thank you very much.
All right. Thank you.